This is basically node, like how to create a node. Now we have n1, n2, n3. These three nodes we have, and we'll see how to create the linked list basically. So for linked list, here you can see this is a linked list class, and it has self.head equals to none. Means initially we don't have any linked list, but we say self.head, it's our none, right? Now when we check about the methods in linked list is like this. We have to add the elements, and how do we add? We need to have data, as we have seen earlier here. If you just have the reference, right? Okay, so these nodes we have just nodes. Okay, then we have to add the data. Now this is the append method of adding the data in linked list. So here you can see we say new node is node with the data that we will call in this method, append method, and we'll check if self.head means this one. Linked list class has this initiated method which is self dot head, which is initially none, right? It is initially none, means we don't have any head at this moment. So we'll check if not self dot head, means we don't have any head, we will assign self dot head equals to new node. Now when we first add this node, we have n1 node with data 10. So what we will call from this linked list class, this append method, by passing 10. So what will happen? It will assign this self dot head equal to new node, which was this n1. So we'll say like node 10, and here just for checking, you have now one node with data 10. Okay, with data 10, and here if you see, when we say node at this data, it also has next pointer, right? Means node dot next. When we do new node dot next, currently it will be none because we haven't added another element, right? So in this case, and it will assign here and it will be returned. Now it will return when we second time add the element. So here now we have second and 2 node. This time what will happen, when we append the data, now the data first it was 10, now it is 20. Now when we add 20, that time it will come, it will assign new node equals to will be node this 20. Now we will have 20 this node, but we'll check if not self dot head, but self dot head is not none. Now we have already some value here, right? Node 10 is there already because we have one node, so it won't come inside this loop, it will just come here, right? Current pointer, our current pointer will be self dot head, means this 10, right? Self dot head, and what we will do, we will just check while current dot next is not none. Here we have current dot next is none, right? Because here you can check next is none because this was the first element. So in this case, it won't go further inside the loop because we don't have current dot next. So current dot next will be, current is 10, means here we have pointer here only. So current dot next will be the new node, means the node which is this 20 current dot next. Now we have added 20 and this node will point to none as of now. this is next, because we don't have any element there. Similarly, when we go further for this node where we add 30, that time again, now the value is 30. This time it will check, it will create new node which is 30, right? And will check self.head. Again, this is not none. Still we haven't updated the head. Our head is still 10, right? Then it won't go inside this, and it will assign our current pointer will be self.head, which is already 10, and it will again be 10 because this is our head, and it will do while current.next is not none. Now for this head, current.next is 20, right? So this is not none. So we will update our current pointer. So current will be current.next, which is 20. Right, now your current pointer is here at this point of time. Now it will again go inside the loop, and it will check if current.next is not none. We check it is none, right? We don't have any element. So what we will do, we will, now it will come outside the loop, and current.next will be updated to the new node, which is 30, right? And again it will point to none, and so on. So this is how the linked list is implemented. Basically, it has multiple functionalities, like you can remove the elements, you can add new elements inside the linked list by just changing the pointers, basically, because we have these pointers pointing to the linked list 10, 20, 30, right? And if you have to add 40 in between that, you need to break this connection, means this pointer dot next will be this, and its next will be this element. So before breaking the connection, you need to store it somewhere, right? So similarly, here I would like to mention one more thing, which is very important, or we can say very mostly asked interview question, like reversing linked list. Okay, so reverse linked list. Okay, so this is basically mostly asked. So what we have to do here, we have a linked list like 10, 20, 30. We have just created this, right? So for this linked list, you have to reverse it. The output we have, that will be, we have these nodes, right? 10, 20 and 30. The only difference will be, we have to reverse, that means this should point here, this should point here. Now this case, this was our head, and in this case this will be head. This is mostly asked question. Okay, and code for this you need to understand, basically, like how to implement the code for this one is basically, let's see what we will do. Let me get this pen. Yeah, so while reversing, now you have this node, right? We have a node which is 10, and it is pointing to some other element, right? And this is our current pointer, right? And for reversing, the most important thing you need to understand, when we reverse that, when we check forward way, you see here, this is forward, and we use next pointer for forward, right? And for reversing, we need to go backward, and for backward, what we will need, previous pointer, right? So this is how the difference is. Here you can see current, and we have a next pointer, but for reversing you will require previous pointer, previous, right? So this is previous pointer, and this will be break, and this will point here. As you can see, this actually pointed like this. So this is the next pointer, this is previous of some node, right? So this is a basic concept about reversing the linked list. It might be becoming lengthy, but I'll try to explain it with very easy format. So first of all, before reversing, we need to say like we will require previous pointer, right? Which we will say initially is none. Our previous pointer is none initially, right? And will require current pointer, which is head, which will be head. Now this is our current pointer, right? Current pointer is 10. So current is 10. What we will do, we'll keep on checking while we have a current. While this current is not null, we will change, we will shift next to previous. But as I have already informed you, right, before breaking the next node's link, we have to first store this element, next one. So we will store it like, let's say our next element is current dot next, right? So we have stored this at this point, this is 20. So we have stored 20 in next pointer. Now our next is equals to 20. What we will do, we have to shift the pointer. So our current dot next. So current dot next will be the previous pointer, because let's say previous, because it will point here somewhere to none or something, okay? Because we don't have, previous is our none, right? So it will point to none. This is our current pointer. Now we have reversed this node basically. Now let's go further. We have now previous, we need to update this previous pointer. Now we have changed the link, this one. Now we will go further, our previous will become the current pointer, okay? This current will become previous, and we will update the current pointer to the next one. Now we have to shift this one, right? This pointer basically. So next, we have stored that in next. If you just understand the flow of reversing is something, first we have next, and next is assigned to new, like current dot next, right? Then here you can see opposite, we update current dot next to some other pointer which is previous, and then here we update previous, the one that we do, or like make changes, we have some operation that we update, right? Now we have previous, then we make current pointer, we have a current pointer, then we have updated the current to the next pointer. That's all. You need to keep this flow in your mind basically. You need to understand this flow basically, and with this you can reverse the linked list easily, right? This is a normal code, and what will you return at the end? Return, we will return. Now when you do something like that, at the end your previous pointer, because at the end current will be assigned to the previous pointer. When you reach here, previous pointer will be this, and your next will be, suppose next current dot next is none in some case, so your current will become none. So you have to return prev means previous pointer, which will be your new head. Okay, so this is what you need to return. This is basically a normal Python code, and there is one more method which is basically to reverse the linked list. You can also use recursion method, which is the easiest one. I'll quickly show you how you can do that. So for using recursion, you need to first have the same, you will have the method like reverse list, or you can say linked list. Okay, so this, and you will always have a head, because head you need to pass always whenever you create a function. Okay, this is a head means this is a linked list. Okay, that's all. So you have to pass this head, and here same thing we will check. The none check-in you can do, that is fine. Like you have to check if the head is not null and all, so that you can do. Let's check about the recursion. Recursion will be, we'll create new node, or we can say new head. Now initially we have to assign the head, but we'll recursively call this reverse linked list. This function basically we will call, and we will pass head dot next. Head dot next means first we pass head, head dot next will be passed again and again here in this recursive call, and we have to update our head dot next next to next basically to our head. Whatever head we have, that will be assigned, and here we say head dot next will be none, and at the end here you have to return new node, because always this new node will have the end of this pointer. When you do this, perform this, and it will call again and again like this, and we will change the head dot next to the head, and so on. Okay, that's all for today's session. Thank you for watching.